All right, everybody. In this video, we're going to do one example of something that your teachers are going to ask you to do called area of the shaded region, which is the example that you can see on your screen here. And then we're going to do a couple examples of what many teachers call composite area or complex area or compound area. And those three things will all mean basically multiple shapes that are glued together to make some unique shape. So here we go. This one says calculate the perimeter and the area of the shaded region in the drawing of two circles at the right. Round to the nearest tenth, show all works. So perimeter is easy, and I stole this from some other worksheet on the internet, but I'm assuming that it wants us to find the perimeter of the outside edges, which just means that we're going to do 12 times 2 plus 6 times 2 because this is a rectangle. So 24 plus 12, my perimeter is going to be 36 inches on this one. Now, the area of the shaded region is a little bit more complex. So basically, I want you to think of this like you have a sheet of construction paper and you're doing a craft, and your construction paper, you're going to cut out these circles. So you're going to do the area of the rectangle minus the area of the circle times 2. And that's going to give you your area of this shaded region that's on the outside of your circles here. All right, so here we go. My area of the rectangle is the length times width. So we're going to have 12 times 6, 12, 24. So this is 72 inches squared. And then we are going to subtract from that my area of my circle times 2. So my circle is going to be pi r squared, and I have 2 of those. So I'm going to have 2 pi. And my radius here, because this is 6, my radius is going to be half of that. So my radius is going to be 3. So 3 squared. So we have 2 pi 9, so 18 pi. Let's punch that into our calculator here. 18 pi is going to be 56.55 if I rounded. Now I hit the pi key in my calculator, so if you use 3.14 instead, your answer might be slightly different. So we still have inches squared here, and we have my 72 inches squared here, and we are still subtracting those. So when we subtract them, I have 72 and I'm subtracting 56.55, and I get 15.45 inches squared as my shaded region up here. All right, here is one of the examples that I mentioned where it's like two shapes glued together. This one appears to be a rectangle glued together with a triangle. Now, some of the ones that you'll see, like for example, this one, oh, nope, this is a bad example also, but some of them will not have that dotted line dividing up your shapes for you, so you might have to draw those lines to divide up your shapes on your own. So let's calculate perimeter first. So if this is 3.5 and we see this little right angle right here, then we know that this is 3.5 up here as well. So if we're finding all the outside edges, we're still missing one piece here. We don't know what this is, but we do know that this is going to be a 4 and that we have a right angle right here. So we can do 3 squared plus 4 squared equals x squared, which all of this is going to be 25 equals x squared, so 5 equals x. So you might have recognized that automatically as a Pythagorean triple here, but not everyone recognizes those. So this would be 5. So my perimeter here is going to be my 3.5 plus my 3.5 plus my 4 plus my 5. And that, and I'm missing one more, 3. So I have 1, 2, 3, 4, 5 pieces. 1, 2, 3, 4, 5 pieces. Just making sure I had everything. So 3.5, 3.5, 7, 8, 9, 10, 11, 16, 19 meters in total all the way around. All right, now we need to find the area of this composite figure. So I have a rectangle and I also have a triangle. So my triangle, this piece right here, is a right triangle. And in right triangles, this would be my base and this would be my height. So my base is 3, my height is 4, area is 1/2 base times height, or just base times height divided by 2. So I'm going to have 3 times 4 divided by 2, 12 divided by 2, which is 6 meters squared. So that's going to be that piece. Now we need this piece right here. So my area of a rectangle is length times width. So 3.5 times 4, which is, what is 3.5 times 4? Oh, 14. I could have done that in my head. I just feel pressured when I'm on videos. So 14 meters squared. So my total area is going to be, so area of the total shape right here is going to be, I'm going to add those two pieces together. So I have a 6 here, and I have a 14 here, and I altogether have 20 meters squared. Okay, here's an example of a word problem. Let's zip through this real quick. So the school's athletic director wants to seed the field and replace the fence. The field is shown at the right. How many meters of fencing? So if I am talking about meters of fencing, that's going to go around. And so this is going to be perimeter. So we know a couple pieces of my perimeter. We know that this is 50 because this and this are congruent. But the piece that I don't know is this piece right here and this piece right here. But the cool thing about this one is if I put those together, I end up with one complete circle. And we know that has a diameter of 30. So remember, perimeter in a circle is circumference, which is either 2 pi r or pi times diameter, where r would be the radius. In this case, we have a diameter of 30. So my circumference is going to be pi times 30, which is 30 times pi is going to be 94.25. And we have meters. So now the last thing we need to do in order to find the total amount of fencing is add 50 and 50 to that. So my distance all the way around is going to be 194.25 meters of fence. All right. And then next, we need to figure out how much grass we're going to need to fill up this entire field. So in this case, this is another compound or composite area where I'm going to do the rectangle, which is 30 by 50. So if area is length times width, we get 30 times 50. So I'm going to have 1,500 meters squared. And then we still have this piece here and this piece here to contend with. Again, when we put those two pieces together, we end up with a full circle that has a diameter of 30. If I divide that by 2, I get a radius of 15. An area of a circle, which is going to be the grass, is pi r squared. So I'm going to have pi times 15 squared. So 225 pi is going to be 706.86 meters squared. So my total area is where I'm going to add those two things. So I have my 1,500 and I have my 706.86. And so my grand total, so plus is 1,500 plus 706.86 is 2206.86 meters squared, and that is going to be my grass seed. Bye for now.